Thank you for the invitation, and I'm glad to give a presentation about the computer vision meets title as computer vision meets social network. Actually, in these slides, I will introduce the work that we have done in Tencent AI Lab, and this techniques is one of some research topics in our labs, and then these topics can be shifted with the product of our company. Okay. First, I will give an brief introduction of our company. So I'm not very sure whether have you heard Tencent before. Actually, Tencent is one of the largest internet company. I think that I can say that not only in mainland China, is over the world. So this is one of the largest internet company, and the market capitalized is $500 billion. So I think that even comparable with Facebook, or even larger than Facebook in some times. And also, we have several products and in several trends. For the most important one is social media, social network. So we have WeChat, and this is WeChat. Also, we call it Weixin in Chinese. So WeChat and also QQ. So this is two types of instant messenger, something like the Facebook and Instagram in US. And also, we have games, and the Tencent Games is the largest, I think that's the #1 game company. We have the revenue of in the US with over $10 billion in 2016. And we have several, maybe someone is familiar with Supercell, which we have already acquired 80% of its shares. So this is, we think that we are the largest, we are the owners, or the 80% shares owners of Supercell. And also we have some content, working on the content, something like the Tencent Video. This is something like the Netflix. And also the Tencent Music, this is something like Spotify. And we have the largest copyright in the mainland China for the music ones. And also we have Tencent News. So this is about content. And also, because Tencent is one of the largest internet companies, so we have the other, the business, such as finance or insurance or something like that. This is all based on internet. Okay, so this is the main introduction about Tencent. And in the next, I will give a brief introduction about Tencent AI Lab that I'm now in. So Tencent AI Lab actually is founded in 2016, and we have 2 locations. One is in mainland China, in Shenzhen, mainland China, and one office is in Seattle, USA. Okay, actually we have 4 research topics, and the center is the machine learning. We focus on the basic machine learning, the machine learning series, and also large-scale machine learning platforms, and as well as the infrastructures. And based on the machine learning part, we have 3 application research areas: computer vision, language, and speech. And we would like to do something, actually, for this, we focus on the areas of this application, and we do some reinforcement learning for the decision, and also generation for the creation. And also, we would like to maybe make some cognitions for the understanding of the world, of the humans of the world. Okay. So in the following of this lecture, I will give an introduction about computer vision, the work that we have done in computer vision. And from the low-level image and image video processing to the middle-level image video analysis, and even the deeper ones, the image and the video understanding. Okay, and we have done several works here, such as the style transfer, enhancement, and super resolution, and dehazing. I would like to select some topics that have already, this technology, we have already got paper published and also shipped to the product. And the second is the image analysis. I will try to introduce some post-estimation and the video interest, attractiveness, and video classifications. And also in the last, for the even hard, deeper learning, deeper understanding of the videos, I will give some images. I will give some introduction about the captioning and also the natural language video localization. Okay. First, this is the video style transfer. This is give a brief image about the video style transfer. And we have the videos and we have a style image. And we perform the style transfer. We would like the style image videos to preserve the content of the video sequences. And also it will borrow the style information from the style image. And the most important thing, this is very popular in 2016 as the Prisma. But nowadays, for the video, we are the first working on the videos. For the video, this is the most important thing is to maintain the temporal consistency between adjacent frames. So from the circles here, the temporal we have compared with the traditional image style transfer and compared with our proposed method, the traditional image style transfer cannot maintain the consistencies. So the circles and the bound boxes there, you can see that the style changes significantly. But for our video part, it can maintain a good consistency. So this will eliminate the flickering artifacts in the videos. Okay, so this is the main network of our video style transfer. And the first part is the stylizing network. This is very traditional, and we have an encoder-decoder style, and we have the encoders, and we connect with 5 rest blocks, and then the decoders. And after that, we realize the loss networks to compute the stylized network and the content loss network, and also the temporal loss. So with this loss well designed, we can train the networks to make the network can preserve the content, and as well as introduce the style, and the most important thing, can preserve the consistency between adjacent frames. Okay, so for this special training, we have the 2-frame coordinated training. So it means that we input the adjacent 2 frames into the network, and then utilize the specific design loss function to train the network. And also, Another advantage is that we do not need to compute the optical flow information on the fly. So it means that we can well make the inference very fast, because we do not need to compute the optic flow. Normally, the optic flow is the most complicated part in video parts. Okay. Another thing is that because we are, this is instance message. This is instance message APPs. So the persons will share their pictures with their friends. So the pictures may be taken in under different conditions. For this case, we want to handle makes the image quality enhanced, but for the low light images. So we have, if you take an image in the low light, you cannot find the edge of the content, and also the colors, you cannot detect the right colors. So we propose a method to enhance the low light images. And we have the image here, and we make it split to the original video part, image part, and also the edge part. So because the edge is the most salient to the human perception. So for the low light input original part, we use an encode-decode style to encode the image and decode the image, get the original results. And also for the edge part, we utilize also something like the encoder-decoder, and afterwards we have the skipped layer and with the RN style to get the edge information. Then base this to the content information and also the edge information. We combine them together, then to have an enhanced quality of the images. And then we get some perceptual losses and also adversarial losses to enhance the quality of the image. Okay, this is some of the results, and we have the first row is the low light images that were provided, and we use our network. We can well recover the content of the image, and also the colors can be well preserved. Okay, so this is one part of we can share the image and improve the image quality. And the next work is mobile pose estimation. Actually, for the pose estimation has been well studied but for the mobile part, we need to perform the network compression and also make it to detect the skeletons or the joints very accurately. So in this part, we're mostly focusing on the network compression and the network pruning. Okay, so we shifted the network from the PCs to the mobile ones, and we can perform the detection of the person and multi-persons, and also for some front and background and something like, and also instances to the colors of their clothes. And this is the demos here, and the left, I think that this is maybe for the projection part, so this is not for real time. And this is the 22 key points for the joints of the persons, and the left one is we consider to detect the hand, because the hand detection will facilitate our, the touchless interaction with the phones or the TVs. Okay. And also for our mobile pose estimation, we have some, you can see that for this one, we are robust to the full or half body, the conclusions on the half bodies. And also we are able to perform a single or multiple persons. And also we are insensitive to the dressing colors or the dressings. And also we are robust to the front and back. Even from the front and back, we can detect the joints and the informations of the skeletons. And also we have already deployed these techniques into mobile QQ. And for this one, this is the right one is the detector of multi-person of the skeletons, and the left one is that we have the skeletons, and we can have a dancing machine, so you can follow the guidance and perform the dances. And then this is very interesting to interact with the phones or interact with the TVs. Yeah, so you can, with this one, we can find with this pose detection, we can match your positions with the designed or the specified the actions. Okay, so this is our work on the pose estimation. Okay, and another topic is very interesting topic is for the video attractiveness. Now, because we have the Tencent video, so we have a lot of video dramas or a lot of TV series uploaded on the website. So we want to find whether the users is interested to some part of the videos. So we would like to examine whether we can predict the video attractiveness from only the visual information or the audio information. So for this one, we have the video input, and we have the video input, and also it's associated with the audio input. And we would like to predict its attractiveness. And the ground truth is the orange line, and the predicted ones is the blue line. Actually, for this attractiveness, it is very hard to get the ground truth data. So we utilize the views, because this Tencent video have a lot of registrators. So there are many viewers at this time. So for each of these values in each point, it means that at this specific time, how many persons have already watched this video sequence at this specific time. So statistically, the larger of the number, it means that there are a larger number of persons watch this video at this moment. So this moment should be the much more attractive than the other with smaller values. So we utilize this value as the attractiveness ground truth value. Okay. So for this task, we built a large-scale data set. We have about 1,000 episodes, and in total about 7-8 hours. And we consist of 270 episodes of American dramas, and also 32 Korean dramas, and also 7 episodes of Chinese dramas. So we have this one, we consider diverse of types, and we have also the view information. We can make it the robust to the video attractiveness study. And for this is statistical information of our data set. And this is the number of the episodes, and this is the number of the views, attractiveness, the views, and in the log ones, in the log. Okay. And also besides of the views, actually because this is for the Tencent video, for the video platform, you will have some of the other metadata or some other user engagement information. The other 9 engagement information we crowd is start of the forward and the end of the forward, the start of the backward and the start of the end of the backward, and also have some bullet screens, and the number of the bullet screens and the likes of the bullet screens, and also we have the forward skips and the faster rewind skips. So with these ones, we can get another more information about the user engagements with the videos. With these user engagements of videos, you can get more detailed information about the video attractiveness, and we can based on these engagements to analyze more about the human behaviors. Okay, as we mentioned before, we would like to make a prediction about the attractiveness from the audio and the video, audio information and the visual information. So for these two different modalities, because we have an audio part and the visual part, so we propose three different fusion strategy. One is in the low level, and one in the middle level, and one in the high level. And this is the three architecture of the fusion part. And we have also in each part we perform context gating here. Okay, so based on this architecture, we perform the prediction, and we also propose the three criteria to evaluate whether we can actually perform the accurate prediction. So we have the 4 metrics, and then we compared with different visual representations from VGG to Inception to ResNet, and for the audio part we compared with MFCC and also the WebNet part. So we can see that consider all the audio features and video features together, we can get a better results. But if we can ensemble the middle level, high level, and the low level fusion strategy together, we can get the best performance. So another thing is that another thing to note that is that if we have the engagements. The engagement is that the behavior of the users. So if we can get the engagements, we can make a very accurate prediction on the video attractiveness, because if they like it, it will watch it, and otherwise they will leave these videos. So the human engagement is the most important part indicator of the video attractiveness. Okay, so this is for the video attractiveness study, and also we make some study on the video classification. And as mentioned before, as mentioned by Lisa before, the moments in time, the 3 seconds video study is also about video classifications, right? And then now before that, there's a benchmark data set on the UCF 101. So for this part, we perform the 2-stream. We utilize the 2-stream CNs on the video classification, and one stream is describes the content, and one stream describes the optical information, optical flow. It means that the motion information between adjacent frames. And we propose a principal back propagation net. We forward all the snippets, so the forward information can capture all the information of the videos. But for the backward, we will perform selectively to backward only a selected number of snippets. So one benefit is that from this efficient backpropagation, we can perform efficient training. And another benefit is that we can also perform the snippets in different scales to characterize the different motion information in the videos. Okay, this is our results, and for this data set, the PBNet here, and our PBNet achieved the top 1 error rate is about only 8.6%. So this is smaller than the other competitive models. Okay. Also for the video classifications, we participate in the YouTube 8 million challenge here, and for the YouTube 8 million challenges here, they only provide the features for the visual features and the audio features. So we work on the audio and the video feature to perform the video classification. And for this is we perform a two-level classification. One is in the video level. So the video level, we average all the frames together to get the video representation. And we propose a multi-fusion layer here as depicted here. And then for the classifiers, we utilize a mixture of experts. And the global accuracy precision is about only 0.82. Okay. And also we perform the frame level classification. In the frame level classification, it is very intuitive to have the LSTM and all the GRU to model the sequential data. So for the video feature, this is also can be viewed as a sequential data. So we utilize a bidirectional LSTM and GRU, and also we consider different motions information. So we perform a multi-scale ones. So for each scale, we perform a bidirectional GRU or LSTM, and the JP here, the global average precision is 0.83. And if we consider the video level part and the frame level part together, we can get the JP is the 0.84. And we achieved about the fourth positions over the 600 submissions. Okay, so this is about the video and image and video analysis. Okay. Afterwards, I will give an introduction about some work that we have done on the understanding. One part is the image understanding here, and the image understanding. This is a very difficult part because image understanding, the image captioning, and the image captioning is a very difficult part because we not only to understand the image content, but also we need to learn the language, the properties, or the behavior of the language compositions. And also we need to perform a multimodal interactions between the image and the sentences. Okay, so for this one, here we also utilize a traditional, something like a traditional architecture. For the image, we utilize the image CNN to encode the information, and we get the image representation in the global ones and in the local ones. If we have a CNN here, if you are familiar with the CNN, for the last FC fully connected layer, this is global representation, and for the intermediate convolution layers, this is a local representation. So for each image scene, we can get the image global and local representations. And with this representation, if we have different scenes such as the Inception and ResNet or the VGG, we have different scenes. We will have multiple representation of the image. For each set, we have a global representation and a local representation. And with these different representations, we can perform a multi-stage attention. And the multi-stage attention can first summarize the information from different encoders, such as ResNet, Inception V4, and also the VGG. So we can sample this representation together and also make this representation to interact with each other. And for the attention part, so they can broadcast their information to the other encoder to let the other encoder know what information has been already considered for the generation part. Okay, if we have afterwards we perform the multi-stage attention, then we utilize another decoder to decode these representations to sentences. The decoder normally we can utilize RNN, not RN, and the LSTM and GRU is the most effective RNs. So we have in here we utilize the LSTM. So we have the image encoder getter representation, and we have the decoder to decode the representation into a sentence. Okay. So this is this task is you need to consider the information of the content in the image and also integrate with the sentences to make it to focus on each object during the generation of each word, such as for the persons, you need to pay attention to the objects of the person need to pay attention to the local region of the persons and then generate words. And for the hues, you need to pay attention to the local region of the image and then generates the words here. Okay, so for these things, we propose, based on our multi-stage attention, we have we have submit our results on the Microsoft Coco challenge here. This is the most, I think that is the most influence data set on the image captioning. For each image, it will each image is accompanied with 5 sentences, and there are about 100,000 images, and for each image as it is accompanied with 5 sentences. So I think the pair data for image and sentence pair data, it is about 600,000 pairs. Okay, based on this data, you can perform the training of your model and then submit the results of the test data on the website. And for this website, we have several criteria to evaluate the results. And for these results, you can see that for this is the blue and the blue 1, blue 2, blue 3, blue 4, and also we have the meter, Rog, and CIDR, CIDR. This is for the CIDR, this is the most specifically designed for evaluate the quality of the image captioning. Okay. So for this, we can see that for the C5 and the C40, we can achieve, for all the metrics, we achieve the top one results, and compared to the other models here. Okay. Also, we have transformed. We have collected another Chinese data set. We have an image here, and also we have the image and its accompanied Chinese sentences. And we train the models, and also we deployed we have released the results, and we build a little program in WeChat, so you can experience it if you have the WeChat here. Okay, this is Chinese for intelligent image recognition. Okay, so for this image, for the Chinese, it give a brief introduction, a very good description about the content of the image. Okay, and for this, if we have the image captioning the results, we give an image and give sentences to describe the content of the image. We can perform first, the most straightforward way, it is perform the image description. Another is that we have these sentences, we can perform the image retrieval, and also as well as the image recommendations. And also for the visual dialogues. And the most important thing, if we have the image and the descriptions, we can help the visually impaired image person to read or to see the images. Okay. So this is the work on image captioning. And afterwards, the last work that I'm going to introduce is the natural language video localization. This is also a very challenging task. We want to utilize a language. We given untrimmed video and a natural language description. The goal, we would like to localize a segment in the video which corresponded to the given natural language description. It means that if we have a very long video sequences and we have a sentence described such as a woman reels a kite back in forward herself, we would like to localize this sentence in the videos. So this is a very, same as the image captioning, it is a very challenging because first we need to understand the language, and the next we need to understand the video sequence. But for the video sequence, the understanding is even challenging than images because the temporal, we need to not only consider the image, the spatial content of the image, but also we need to consider the temporal relationship between the adjacent frames. So we propose a single stream natural language video localization network. For this part, we have the video. We have the videos, and we have a sentence that will perform frame by word interactions or matching between the sentence and the video. Then with these matching behaviors, we perform temporal proposals and have different anchors, then we have different scores. With these single stream processes, we can efficiently localize the sentences in the video sequences. Okay. And this is some results of our proposed methods. And this is videos. And this have the sentence: a man in a red shirt claps his hand. And the gray ones is a ground truth. And the green one is we utilize the VGG16 as the image as the encoder. And for the blue ones is we utilize the inception v4 as the encoder. And the yellow ones, we utilize the C3D as the encoder. So you can see that if we utilize the VGG16 and inception v4, we can get a reasonable accurate result. Actually, for this specific task, we outperform all the competitor models on this specific task. And for this data set, the camera zooms out to show where the waterfall is coming from. So you can see that for the fusion, we fusion the inception v4 and optic flow. We can get the accurate prediction on this example. Okay, besides we examine the frame and the frame by word attentions here, and for this sentence waterfall in forest. For this, you can see that for this all video sequences, the forest is appeared over all frames, so the attention values will be triggered as equally. But for this waterfall only appear in the first frame, so it will only have these values here. Okay, and the same observations can be observed from these two given examples. Okay, so this is lots of work that I introduced about computer vision meets with social network. Actually, besides that, in our lab, we not only do the work on computer vision, but also we have some of the other works on the AI projects. The most important one of the most important AI project is the AI plus health, and we would like to deploy or utilize the AI technology to make the healthcare and also the healthcare. The first is that we would like to use the AI technology or deep learning technology to analyze the medical images and to help the doctors to make to help the detector to make the diagnosis. And for these specific cancers, such as the lung cancer screens, for this recognition rate is over 98%. And also in the future, we would like to perform a computer-aided diagnosis, and we have some scripts about the description of the patients, and also we have some medical images about the patients, and we would like to help the doctor to make the diagnosis, and also even in the future, we can help the doctor to design the treatment about some of the disease. Okay. Another important topic is the AI game, because Tencent game is the largest, the #1 game company of the world. So we would like to utilize the AI technology to be more deeply involved in the game, maybe the design, the playing, or something like that, to make the game to be more interesting and more interesting to the players. Okay, so I will give a brief summary here. And first, I will give an introduction about our talk, computer vision meets social networks. And we introduce some works that we have done in Tencent AI Lab, from the research to the product, and something related to image video processing, understanding, analysis, something like that. And also, I have introduced about several our important projects, AI plus X. The X may be health, game, or in the future, some robotics or something like that. Okay, so this is the end of my lecture. Okay, thank you.